All right, so for 12, you have someone who's going to be exercising 20 minutes a day, and then they'll be increasing, adding 5 minutes every consecutive week after that. The question is, how many minutes will they exercise during the 6th week? They want you to write a recursive and an explicit rule for this arithmetic sequence. So, first off, we know that the difference is 5 because we're going to be adding 5 minutes every week. And the initial number, the a sub 1, is 20 because that's where they start. So if we write a recursive formula, we're going to say f of 1 is 20 and f of n is the previous number or the previous term plus 5 for n greater than or equal to 2. So this is the recursive. The explicit f of n equals the initial number, initial time. The difference is 5, n minus 1, for n greater than or equal to 1. So here's that one. Well, actually, we could simplify this one further. So this is going to be 20 plus 5n minus 5. So that's 20 minus 5, 15 plus 5n. Right there. And so for week 6, so we want f of 6, 15 plus 5 times 6, that's going to be 15 plus 30, so that's going to be 45. So Thomas will exercise for 45 minutes. During the 6th week. Alright, so I wrote out the first 3 levels of glass panes. And so if it starts off with 4 on the top and then 4, each row increases by 4, so it's 4, 8, 12. And I just put dot, dot, dot just to stop writing the numbers. And so the difference is 4, common difference is 4. N represents the row number, and f of n represents the number of glass panes. Okay, so we're going to write the recursive. So f of 1 equals 4, and then f of n equals the previous term plus 4 for n greater than or equal to 2. Okay, the explicit would be f of n equals the first number plus the difference times n minus 1 for n greater than or equal to 1. We're going to simplify, so 4 plus 4n minus 4. 4 minus 4 cancels, so I'm left with 4n. For n greater than or equal to 1. So here's the formula. So they want to know on the 17th row, right? So f of 17 equals 4 times 17. So it's going to be 14, 14, that's 30, 68. So there are 68 glass panes on the 17th row. Alright, so for 14, the dress was purchased at $185, but then she gave a $20 down payment, so that leaves her with a balance of $165. Okay, and the following week, she was going to pay $15 down, right? So for every week until she pays off the dress. So she's at $165 right now. and next week she'll make a $15 payment. So right now, and let's see me write it here, and it's going to represent the number of weeks to pay off the dress, and then F of N is the money owed. Okay, that's how much she owes. So we're going to write a recursive, and by the way, on this one, because when she gives a down payment, she owes that money, right? And she's not going to pay the $15 this week. She's going to pay it till next week. So in this problem, N starts off with 0. Okay, because right now she owes $165 and she's not going to pay anything until next week. So for this problem, N is going to begin at 0. Okay, begins at 0. So we're going to do the recursive f of 0 equals 165, because that's what she owes right now. Then f of 1 equals a previous number, or previous term, minus 15. Okay, for n greater than or equal to 1. So there's a recursive. The explicit is f of n equals the initial amount minus, now since we're starting with 0, this is going to be f of n equals minus 15n for n greater than or equal to 0. Okay, and there's nothing to simplify here because there's no n minus 1 to distribute. So that's what it is. Now the question is, how many weeks before she pays it off? So we want to know, when is this number going to be 0? Because remember, this is how much money she owes. F of n. It's how much money she owes. That's what this represents. So every week she's going to be chipping away at the 165 by subtracting $15, right? Each week. So how many weeks is that? So we're going to make this one a 0. And then solving for n. So I'm going to add 15n to both sides. So 15n equals 165. Divide by 15. So n is 11. So it will take Clarissa to pay off the dress. Alright, so for 15, you're stacking some cups to place on a shelf. The shelf has 12 inches of space vertically, but at the same time, you don't want the stack to reach all the way to the top. You want a little bit of space, a little gap on the top. So I'll say, if you notice the difference, the height from one cup to the next, when you stack them up, is 1/4 of an inch right here. So every time they add a cup to the stack, it only increases by 1/4 of an inch, right? So the difference is, or the common difference is 0.25. So you want to leave about that much space above it. So we'll say that the actual space that we're looking at is 11.75 inches. Okay, because we want to leave some space. So the recursive formula is going to be n equals 5, because that's my first number. And then, whoops, let me write f of 1. What am I writing? Not n equals 5, but f of 1 equals 5. And then f of n is the previous number plus 0.25 for n greater than or equal to 2. So there's a recursive. the explicit f of n equals 5 plus 0.25 times n minus 1 for n greater than or equal to 1. And I'm going to distribute the 0.25, so that's going to give you 5 plus 0.25n minus 0.25. And so that's f of n equals 0.25 n, and then this one and this one combined to give you 4.75. Okay? Alright, so now we need to solve for the number of cups that we can fit in the shelf. So remember, f of n represents the stack height, and we want that to be no more than 11.75 inches. So that's what I'm going to replace this side with, the left side with 11.75, and then I'm going to solve for n. Okay, so let's go ahead and do that. 11.75 equals 0.25n plus 4.75. We're going to subtract 4.75. And so I get 7. Okay, so 0.25, another number for 0.25, another way of writing it is 1/4, right? That equals 0.25. So, oops. Okay, so I'm going to change this to 7 equals 1/4 n. And so I can multiply both sides by 4. And I could divide by 0.25 and use my calculator. I can do that too, but usually when it's a simple fraction like this, a decimal that I can convert to a simple fraction, I'll go ahead and do that. So 4 times 7 is 28. So the question to answer, you say you can stack 28 cups on the shelf. And there it is. Alright, for 17 I wrote down the two sequences in a table. And in essence, they are the same sequence because we end up with the same numbers. If we were to write down the sequence, it'd be these numbers and these numbers. So those are identical lists. So we're going to say, yes, they are the same. The sequence itself is the same. For part B, they want you to write an an explicit rule for each one. So for A, we're going to say f of n is, the first number is 1, plus the difference is 2, times n, because we're starting with 0, so n greater than or equal to 0. For B, it's going to be f of n equals 1 plus 2 times n minus 1 for n greater than or equal to 1, because we start with 1 on that one. Okay, and we can simplify b a little bit more, so that's going to be 1 plus 2n minus 2, so that's 2n minus 1 for f of n. So remember, oops, and then n is greater than or equal to 1. It could be this one or this one for the explicit rule of B. And then for C, it's asking you to tell how the explicit rules indicate the geometric relationship between the two graphs. Well, if you look at B, if you look at the graphs, I didn't take a screenshot of the graphs, but graph B is translated to the right 1 unit. So for part C, the only thing you could say is, you know how it's the same list, it's the same numbers in the sequence, but graph B is translated to the right 1 unit. And remember, when we're doing transformations, this n minus 1 translates things left or right, and it's -1, so it moves it to the right 1 unit. So that's what you see on the graph. So you're going to say graph B is translated right